Hello, dear students. Good morning to one and all. Welcome back to the chemistry class. So, in the previous classes, so far we discussed about surface chemistry, and that part one, adsorption and absorption concept, and then catalysis. After that, colloidal solutions. So the colloidal solutions, we have discussed about the classification of colloids, its preparations, purifications, and properties. So in the properties, now in this session, we are going to discuss about the coagulation of colloidal solutions and protection of colloids and emulsions. The last concept of the topic: coagulation, protection of colloids, and emulsions. So let us discuss the first point about the coagulation. Coagulation of colloids. Coagulation is what? What is meant by this coagulation of colloids? So in the preparation part, we have studied about peptidization. See the definition of coagulation and peptidization. So how we are going to prepare the colloidal solution? We have three methods. In that, peptidization is one of the methods. What is meant by peptidization? The process of converting the freshly prepared precipitate into colloidal solution by the addition of some suitable electrolyte. So, freshly prepared precipitate is converted into colloidal range, colloidal solution. The process is called as peptidization. Whereas in this coagulation, it is a reverse process. The conversion of colloidal solution or precipitation of colloidal solution by the addition of some electrolyte, suitable electrolyte, is called as coagulation. Coagulation. So in this coagulation, so what we are going to study, which type of electrolytes we are going to add. The phenomenon of precipitation of a colloidal solutions by the addition of some suitable electrolyte is called as coagulation. And the added electrolyte, that is we can call as coagulating agent. Coagulating agent. Coagulation and coagulating agent. What is meant by coagulation? Precipitation of colloidal solution. That means colloidal solutions is converted into this colloidal solution is converted into precipitate, PPT, precipitation by the addition of some suitable electrolyte, that is called as coagulating agent. Coagulating agent. Coagulating agent. Whereas this reverse process is called as peptidization, where in that case it is called as peptidizing agent. Peptidization. So this reverse process is known as peptidization. The conversion of freshly prepared precipitate into colloidal solution is called peptidization. Whereas conversion of the phenomenon of conversion of colloidal solution into precipitation of colloidal solutions by the addition of some suitable electrolyte is called as coagulation, and the phenomenon coagulation, and the electrolyte which is added is called as coagulating agent. Now let us understand the mechanism of coagulation. How the coagulation is occurred, how the colloidal solutions is converted into precipitate. So first of all, we need to take the colloidal solution and add some suitable electrolyte into this colloidal solution. As you know that colloidal solutions are colloidal particles which carries some charge, either it may be positive or negative. So positive or negative charge. Colloidal solutions, positive colloids or negative salts, positive and negative salts. So some charge will be present. When an electrolyte is added to the colloidal solution, the electrolyte is split up. The dispersed phase particles of this colloids which absorbs, or it is a charged particle which get neutralized by the ions which carries opposite charge. So I have a coagulating colloidal solutions now. In this, suppose it is a positive charge. Now when an electrolyte is added, it containing two ions, A plus and B minus. So this, suppose if it is positive, it is neutralized by the negative ions of the added electrolyte. Right? So the charge on the colloids is neutralized by the addition of an electrolyte. Opposite charge of the electrolyte. So this is the mechanism of coagulation. Usually the colloidal solution is nothing but, suppose, so this is the colloidal solution. In the colloidal solution, I have taken a colloidal particle, dispersed phase particle. Suppose if it is carries positive charge, then the added electrolyte AB, when AB is added, so it contains A plus and B minus. So all the B minus are surrounding to it, and it is neutralized by B minus ions. So this colloidal particles are then neutralized by the negative ions of the added electrolyte. So this is about the mechanism of coagulation. So is it clear? The first point is the definition of coagulating agent, and how the precipitations will occur when an electrolyte is added to the colloidal solutions. Mechanism of coagulation. So you can consider some examples. Either you can take the negative or positive salt, that is colloidal solution, and how it gets neutralized by the addition of an electrolyte which containing opposite charge. If the colloidal solution is positive, then it is neutralized by the negative ions of the added electrolyte. If it is negative, then it is neutralized by positive ions of the electrolyte. So this is about the coagulation. For example, arsenic sulfide. Example, AS2S, arsenic sulfide. Or you can take FeOH plus ferric hydroxide. As you know that usually metals and its sulfides are negatively charged. So this is negative charge, this is negative charge. Whereas oxides and hydroxides of metal, are positively charged. It's positive or negative? Yes, it is positively charged. Oxides and hydroxides are positive charged. Oxides and hydroxides are positively charged. So these negative charged colloids are neutralized by the positive ions, whereas these positively charged colloids are neutralized by the negative charge of the added ions. So this is explained by Hardy's culture. Hardy's culture. So here is coagulation. So in order to coagulate, or in order to convert this colloidal solution into precipitate arsenic sulfide, we are going to add some positively charged or any electrolyte which containing positive charge. For example, we can add Na plus, sodium chloride, magnesium chloride, etc. Mg2 plus, Al3 plus, etc. There are different positively charged ions are there. So which electrolyte is suitable in order to coagulate this solution? Similarly, In order to coagulate ferric hydroxide, the negative, for example, FeCl6 ferrocyanide ions 4 minus, efficiency. Phosphate ions are there with the 3 minus, phosphate ion, sulfate ion, Cl minus ion, etc. So different negatively charged ions we can add to the colloidal solutions in order to coagulate these salts. Now the question is, which electrolyte is preferred in order to coagulate this? Or which one is the best electrolyte coagulating agent? Which of the following is best coagulating agent in order to coagulate arsenic sulfide? And which of the following is the best or suitable for the coagulation of ferric hydroxide? So here the Hardy-Skulls rule which states that greater the charge or valency of the active ions added, greater the valency or charge on the active ion, coagulating ion or fluctuating ion. We can call fluctuating ion added to the colloidal solutions. More will be the coagulating or easier will be the coagulation. The process of coagulation becomes very fast if the charge carried on the active ion is more. Greater the valency, greater will be the coagulation. So that is the Hardy-Skulls rule. So Hardy-Skulls rule which says that greater the valency of active ion added, greater the valency of fluctuating ions or coagulating ion or active ion you can call. Greater the charge of it, greater will be the coagulation. Greater will be the coagulation. That means the coagulation process is directly proportional to charge on the active ion. Charge on the active ion. Either it may be positive or negative, depending upon the type of. If it is negative solve, then we need to consider the positive. So in this case, Al plus 3 charge, it is plus 2 and it is plus 1. So for this, in order to coagulate the negative salt, Al plus 3 is more effective for the coagulation of this. Whereas in order to coagulate ferric hydroxide, FeCl6 to the power minus 4 is the charge. Greater the valency, greater will be the coagulation. Greater the valency, greater will be the coagulation. So this is about the coagulation, the Hardy-Skulls rule. You can know this Hardy-Skulls rule. Greater the valency of active ions, more will be the coagulation. More will be the coagulation power. Note down the Hardy-Skulls rule. Hardy-Skulls rule. What it say? Greater the valency of the active ion, greater will be its coagulation power. Or yes, right. So Hardy-Skulls rule, what it states? It states that greater the valency of active ions. Active ions are what we are adding is coagulating agent. So it containing the ions, coagulating ions or fluctuating ions are written of active ions. Greater the valency, greater will be its power to cause coagulation. Yes, greater the valency of active ion added, more will be its coagulating power. That is the Hardy-Skulls rule. So according to this Hardy-Skulls rule, in order to coagulate this, what is the correct order of the fluctuating ions? So here Al3 plus having higher value of coagulation. Sorry, it having higher coagulating power and coagulation values are different. So here what is meant by the coagulation power and what is the difference between these 2 points? Coagulating power, coagulating value, or fluctuation power and fluctuation values. What is the difference between these 2 terms? So look at this. If I have taken a colloidal solutions, I have taken some amount of colloidal solutions. I have taken in this. So suppose if it is a negative solve, let's say arsenic sulfide, negative solve I have taken iron. To convert this colloidal solution into precipitate, conversion of colloidal solution into precipitate by the addition of some suitable electrolyte. By the addition of some suitable electrolyte. So here I am adding some electrolyte. I am adding some electrolyte AB. AB is an electrolyte I am adding. So how much electrolyte is required for the coagulation of this? Sorry, for the precipitation of this colloidal solution. So in order to convert this colloidal solution into precipitate, as you know that precipitate means what? Insoluble solid forms in the solution. So here the dispersed phase particles which carries negative charge, which get neutralized by the positive ions of the added peptidizing agent, and it get neutralized and it settle down. So colloidal solution is converted into PPT, precipitate. So in order to convert this colloidal solution into precipitate, how much electrolyte is required? Some minimum amount of electrolyte is required, below which the precipitation or this process, coagulation process is not possible. Suppose if it requires, let's say if it requires 10 grams, and if you are adding only 5 grams, is the coagulation process can occurs? No, it do not occur, because in order to coagulate, 10 gram is required. Just assumption. So some minimum amount of peptizing, minimum amount of coagulating agent is required. Minimum amount of electrolyte which is required in order to cause the coagulation is called as coagulation value. The minimum amount of electrolyte which required for the coagulation is called as coagulation value. Coagulation values. Whereas coagulating power is nothing but tendency of that ion to cause coagulation or to neutralize coagulation power. So here this coagulation power and coagulation values are inversely related with each other. Inversely related, right? Coagulation power and coagulation values. Because suppose let's assume that I have added two ions A plus, B plus, C plus, D plus. Four ions I have A plus, B plus, C plus, D plus. So I am adding one by one in four different cases. So suppose 2 grams of A plus is enough, 3 grams, 4 grams, and 5 grams. General values I am considering 3, 4, 5, 2, 3, 4, 5. So 5 grams of D is required to coagulate this colloidal solution. If I am using a B electrolyte, then only 3 grams is enough, and 2 grams of A is enough, 4 grams of C is enough in individual cases. So here, which one is best coagulating agent? Of course, only 2 grams is sufficient to neutralize the charge carried by this colloidal solution means. So this having higher power, coagulation power. So minimum, lower the value of lesser the value of coagulation, then greater will be its power to cause coagulation. So here we can say coagulation power is inversely related to coagulation values. Coagulation power. So coagulation power of electrolyte coagulation power of electrolyte 1, coagulation power of the electrolyte 2 is equal to coagulation value. This is equals to coagulation value. First electrolyte by coagulation value of second. So you can take the ratio coagulation power of power of coagulation, power of electrolyte 1 by 2 is equal to coagulation value of 2 by 1. Coagulation value of 2 by 1, that is inversely related to each other. So lesser the value of coagulation, more will be its power to cause coagulation. Coagulation power and coagulation values are inversely related. So this is about the coagulation of the colloidal solution. Coagulation of the colloidal solution. The next concept is about protection of colloidal solution. Protection. Now look at this. So this is a colloidal solution. When some electrolyte is added, this the charge carried on the colloidal solution is get neutralized and it is converted into precipitate. So in order to avoid the precipitation of colloidal solution by the addition of some electrolyte, we need to use some other substances, other electrolyte solutions. That is we can call as protecting colloids. Some amount of protecting colloids. Usually, the precipitation of lyophobic colloids by the addition of some electrolyte can be prevented by the addition of some protective colloids or lyophilic colloids. That added lyophilic colloids is called as protecting colloids. Protecting colloids. So here, coagulation is nothing but the colloidal solutions is converted into precipitate by the addition of some electrolyte. So this process is prevented by the previous addition of some electrolyte or colloidal solution called as protecting colloids. So coagulation can be prevented by the previous addition of protecting colloids. So how this is carried? So what is the concept of protection of colloids? So let's discuss the protection of colloids, coagulation and protection of colloids. Protection of colloids. Protection of colloids. Protection of colloids. So here, the term protection of colloids, yes, itself is giving the meaning protection for the colloids. So colloids, it should be colloids to the colloidal solutions. When we are adding some electrolyte, it is converted into precipitate. So this the process or the phenomena is called as coagulation. This coagulation can be prevented by the addition of some protective colloids. So here let us consider some gold salt. The gold salt can be precipitated by the addition of sodium chloride solution, 10% sodium chloride solution. So in order to prevent the precipitation of the colloidal solutions, so this is the colloidal solution. To this, we are adding some electrolyte that is called coagulating agent. Coagulating agent, and this is colloidal solution. So when coagulating agent is added to this, what happens? The colloidal solutions is converted into precipitate. In order to avoid this, some protective colloids we need to add. Protective colloids we need to add in order to avoid the coagulation of the colloid. So this is called protection of colloids. So usually this will be lyophobic colloidal solution. Lyophobic colloids are precipitated by the addition of coagulating agent. To avoid this, some lyophilic colloids is added previously or before the addition of coagulating agent. Before the addition of coagulating agent. So this is called protection of colloids. So in this part, they can ask about the gold number. So here, gold number. Gold number. Gold number is nothing but the number of the amount of protective colloids in milligrams required to prevent the 10 ml of gold salt by the addition of 1 ml of 10% NaCl is called as a gold number. So the amount of protective colloids in milligrams required for the prevention of coagulation of 10 ml of gold salt by the addition of 1 ml of 10% NaCl. So here 1 ml of 10% NaCl. 1 ml of 10% NaCl. When it is added to the 10 ml of gold salt. 10 ml of gold salt, 1 ml of 10% NaCl. So just to prevent the coagulation of 10 ml of gold salt by the addition of 1 ml of 10% NaCl, how much amount of protective colloids is required, that is in milligrams, is called as gold number. Gold number is defined as it is the amount of protective colloids in milligram required just to prevent 10 ml of gold salt from the coagulation 10 ml of gold salt by the addition of 1 ml of 10% NaCl. 1 ml of 10% NaCl is called as gold number. Gold number. You can note the definition of gold number. The amount of protective colloids in milligram required to prevent the coagulation of 10 ml of gold salt with addition of 1 ml of 10% NaCl is called as gold number. Gold number. This is about protection of colloids. Please note the definition of gold number. The minimum amount of protective colloids in milligram required to just prevent 10 ml of gold salt, 10 ml of gold salt by the addition of 1 ml of 10% NaCl solution. 1 10% NaCl solution. Yes, this is about coagulation and protection of colloids. And the last remaining concept is about emulsions and its type. So just note the definition of emulsions and types. So what is meant by emulsions? What are the two types and some applications of about colloids? So here just note on the heading emulsions. Emulsions. So in the first part, there is in colloids, in the classifications we have studied the different types of colloids based upon depending upon the dispersive phase and dispersion medium. So emulsions, can you identify the dispersive phase and dispersion medium in emulsion? Yes, in dispersive phase and dispersion medium, both are liquid. Both are liquid. So liquid particles are dispersed in liquid medium. So both the dispersive phase and dispersion medium are in liquid phase. That is we can call emulsion. So usually this emulsion, when two liquids are mixed with each other, usually the liquids are, for example, water and oil. When it is mixed with each other, whether it forms homogeneous or heterogeneous solution. It forms heterogeneous because both the layers are separated. So emulsions can be prepared by vigorous shaking of two solutions, or else by adding it into homogenizer, an instrument in which the solutions can be prepared. Because this emulsions, when it forms, it is highly unstable. So when it is kept for some times, both the layers are get separated. So in order to stabilize the emulsion, some amount of some other substance is added called as emulsifying agent. So this emulsifying agent or emulsifier, which stabilizes the emulsions, which can stabilizes the emulsions. So in this emulsions, it is of two types. One is water in oil or oil in water. Oil in water. Second one, water in oil. First one is oil in water, and second water in oil. So here, oil in water or water in oil. Two types of emulsions. Just note the examples of this. Oil in water is nothing but in this type of emulsion, the dispersed phase is oil, that is both are in liquid. So here, for example, milk. Milk is an example of this type. Milk. So in this milk, the liquid which gets dispersed in water. The liquid fat get dispersed in water. So water is a medium and the liquid fats are the dispersed phase particles. Dispersed phase and dispersion medium both are in liquid. Vanish creams, milk are the example. Milk is an example of this kind. So second example is vanishing cream is another example. Vanishing creams is an example. In this case also, the liquid particles are dispersed in water. Oil in water type of emulsion. Second one is water in oil. This is not one example. Water in oil, butter, cod liver oil, cold creams, etc. So for this type, butter, cod liver oil, cold creams, etc. Cold creams are the examples of water in oil. So in this case, water acts as a dispersed phase and oil acts as dispersion. First term, dispersed phase, dispersion medium. Dispersed phase, dispersion medium. Okay, and some of the general applications we can know now about the emulsions. So in the next class, we begins the new topic. If you have any doubts regarding this topic, surface chemistry, we'll discuss in the discussion hours. Okay.